Everyone, welcome to a new video in Statistics and Probability. Again, this is Sir Neil, and on this video, I will be discussing about our Lesson 3 in Module 2, which is probabilities or areas of the regions under the normal curve. So, let us be familiar first of the concept of probabilities. So we have these probability notations. Suppose we have symbols or read as, or probability notation is read as probability of Z is greater than A but less than B. Okay? So this actually means that the probability that the Z value is between A and B. Now, it looks like this in our normal curve. So, this would be our A from here to this point of Z, or Z is equal to B. So, we are looking for the area between these A and B, where A are specific values of Z. Now, suppose we have this kind of symbols or probability notations. It is read as probability that Z is greater than A, or probability of Z is greater than A. So, it means that it is the probability that Z value is above A. So, it would look like this. So, suppose we have a specific value of A, which is Z is equal to A, or a number. This is a specific number or value of Z, and the area above it, which is greater than Z is equal to A. Now, we also have symbol like this, probability that Z is less than A. So, it means that the probability that Z value is below A. To illustrate this one, it would look like this. From this point of A, specific value of Z is equal to A, we are looking for the area below it. So if we say less than, it means below. If we say above or greater than, the symbol is greater than, then it means above that specific value of A. Now, if we say between, we have two specific values of Z, then that is between those, the area between those specific values of Z. Very important to note, probability that Z is equal to any value of Z, then it is always equal to 0, since the Z value is equal to exactly 1 point on the curve. It doesn't have any area. Okay? The question now would be how to determine the probabilities or areas of the regions under the normal curve, which is our lesson for this video. Now, let us have the Z table based from the center. Let us use this one since this is the table given in your module. And suppose we have this situation or area less than Z, positive Z value. Suppose we have the area less than a positive Z value. So the probability notation for that is probability that Z is less than A. Now, to solve this kind of probability using the Z table based from the center, we use this operation. So it would be 0.5 plus the table value. Now, to understand why we use this 0.5 plus table value, let us have an example. Suppose we have to find the proportion of the area below Z is equal to 1. This problem can also be found in your module. So, to solve this one, we use that notation this one, probability that z is less than a, which is probability that z is less than 1 is equal to this operation, 0.5 plus table value of z is equal to 1. We are actually referring this to the corresponding value of z is equal to 1 to our z table based from the center. Now, if you use now the z table based from the center in your module, can you look at your module and look for the corresponding value of z is equal to 1. Now, if you already have the value, it would look like this. So it would be 0.5 plus 0.3413. So this is the corresponding value of z is equal to 1 in the table, z table. And then you just add this one, then you get the area, which is 0.8413. Now, the question is, why actually do we have this operation? Suppose we have this 0.5, this one. And we have the table value, since the table value is based from the center, so it always starts from the center to particular value, which is 1. So this would look like this pink. So we are looking for the area below z is equal to 1. So from here and all of this. So that is why we actually need to add. So if it is positive, then we add 0.5. Okay? If we're looking for less than the value. So that would be, if we add this one, then that would be equal to 0.8413. So these two particular areas will be added and it will become like this. Okay? Now, let us have another situation. Suppose it is the other way around, like the area less than a negative z value. So the probability notation for that is probability that z is less than negative a. Now, the operation will change. That would be 0.5 minus t value. Now, to show that one, let us have an example. Suppose we have to find the proportion of the area below z is equal to negative 0.5. We have probability that z is less than negative 0.5 is equal to 0.5 minus the table value of z is equal to negative 0.5. So, as we use the z table, we will get that the corresponding value of z is equal to negative 0.5 would be 0.1915. So, in that case, we subtract 0.5 minus 0.1915, then we get 0.3085. So, to illustrate that one, it would look like this. Suppose we have the 0.5, since that would be our operation. We have here. And then, we also have this one, which is from here, from the center down to negative 0.5 here. So, actually, we want to get the area below negative 0.5. So, we're looking with this excess area here. So, to get this excess, we have the 0.5, the whole half, and then we get the 0.1915, which is this one, this pink. So, if we subtract this pink area to the blue area, we get the remaining area, which is the probability of z is less than negative 0.5. So, we will have this one, 0.3085. Okay? So, it would look like this. Okay? Now, let us have the next example. Suppose we have the area greater than positive z value. So, the probability notation would be probability that z is greater than a. And the operation of that will be 0.5 minus the table value. Okay? So, we follow the operation by applying it to this example. Now, the example here is find the proportion of the area above z is equal to 1.5. So, to solve that one, that would be probability of z greater than 1.5 is equal to 0.5 minus the table value of z is equal to 1.5. So that would be, in your z table, as you look at the corresponding value of z is equal to 1.5, you will get 0.4332. And you subtract that one from 0.5. So, we will get 0.0668. Now, we actually have a very small area here. So, to illustrate that one, it would look like this. Suppose we have the 0.5 and the area from, which is based from the center to 0 to 1.5. So, this would be like this. So, it is 0.4332. Then, we will only get this area, which is 0.0668, which is this one. We're talking about this one. The remaining, that very small area to the right. Okay? Now, suppose we will have the area greater than a negative z value. So, the notation for that would be probability greater than negative a. So, the operation we will follow is 0.5 plus table value. Okay? So, it would be find the proportion of the area above z is equal to negative 2. So, the solution would be probability of z is greater than negative 2 is equal to 0.5 plus table value of z equal to negative 2. So, as we look the area of corresponding area of this or corresponding value of z is equal to negative 2 in our z table, we will get 0.4772. So, we add 0.5 to and 0.4772. So, we will have 0.9772. Okay? So, as an illustration, this would look like this, 0.5. And the area given by the z table, which is from the center to negative 2. So, that would be that one. So, we actually want to have the area greater than negative 2. So, this is also included. And this one. So, we add. Then, we get this one. So, the corresponding area for this, 0.9772 would be look like this. Okay? It's the whole area above negative 2. Now, let us have another example. Suppose this is, we have area between two positive z values. So, if we have this kind of situation, this would be the probability notation. And the operation would be bigger value minus the smaller value. So, the bigger value of those particular z values, we subtract it to the smaller value and we get the area of that. Okay? So, let us have an example. Find the operation of the area between z is equal to 1 and z is equal to 1.5. So, the solution for that would look like this. So, the probability of z is greater than 1 but less than 1.5. Because we're talking about between of this. So, it is equal to bigger value minus the smaller value. So you actually get the area of this. Now, the bigger value is the corresponding value of this 1.5. Okay? The smaller value is the corresponding value of z is equal to 1. So we will get, if we use the z table based from the center, you will have, in our previous examples as well, we have the corresponding value of 1.5 and the corresponding value of z is equal to 1. So we have 0.4332 minus 0.3413. So as we subtract this one, we will get 0.0919. Okay? Now, to picture out this one, why do we subtract? Can you observe this illustration? So suppose we have first the 0.4332, which is the area from the center, since we're using z-table based from the center. So it starts from 0 to 1.5, so that area, this area. And we also have the area of z is equal to 1 from the z-table based from the center, so we will have this one. We're talking about this one. Now, we're actually looking for the area between 1 to 1.5. So, to get this one, we need to subtract this bigger one to the smaller area to get the remaining area, right? So, this would look like this, that one, since we already subtracted that one. Okay? So, suppose if it is the area between two negative z values. Actually, it's quite the same. The situation is quite the same. Okay? But allow me to illustrate. So, the probability notation would be probability of z is greater than negative b but less than negative a. And the operation will be the same. Bigger value minus smaller value. So let us have an example. Find the proportion of the area between z is equal to negative 2 and z is equal to negative 0.5. So, the solution would be probability of z is greater than negative 2 but less than negative 0.5. Okay? So, we will get 0.4772 minus 0.1915. Okay? So, we will get 0.2857. Okay? So, to illustrate that one, suppose we have 0.4772, which is the area given by the z-table based from the center. So, it starts from 0 to negative 2 here. So, that is 0.4772. And the area from 0 to negative 0.5, that would be given by 0.1915. So, if you want to get the area between negative 2 to 0, negative 0.5, we subtract these areas so that we will get this area, which is 0.2858, which is this one. We're talking about this one. Okay? So, lastly, suppose we will have the area between a negative z value and a positive z value. So, the probability notation for that would be probability that z is greater than negative a but less than b. Now, the operation would be different from the previous areas between two z values because they are both the same sign. This time, it has different opposite signs, negative and positive, between a negative to positive z value. So it will be bigger value plus smaller value. In short, you add the areas between, corresponding areas between two z values. So To understand this one, let us have an example. Suppose we are to find the proportion of the area between z is equal to negative 0.5 and z is equal to 1.5. So, in symbols, that would be probability that z is greater than negative 0.5, which is this one, but less than 1.5. So this would be equal to the bigger value plus the smaller value. So the 0.4332 comes from the area of 1.5, and corresponding area of 1.5, and the 0.1915 is the corresponding area of negative 0.5. So as we add this one, we will get 0.5328. Okay? Just add that one. If you have, just add the corresponding areas of those specific z values, and you will get the area between those z values. Okay? So, to illustrate this one, this would look like this. So, from 0 to 1.5, which is, it must start from the center. So, 0.4332. So, this area would be 0.4332 plus 0.1915. Okay? Why do we add? Because we're looking for the area between 0, negative 0.5 to 1.5. So, this one plus this one. So, this would be equal to 0.5328, which is this one. Now, how to determine the area or the probabilities of the regions under the normal curve or the z values. It's actually easy. You just need to remember uh, those operations that I have mentioned. So to have a summary, this would all be the operations you have to take note if you use z-table based from the center. Now, these operations are only applicable if you use z-table based from the center. Okay? You can't apply this one to the z-table which is based from the left. Okay? It has a different approach. So, all you need to remember is if area less than positive, so 0.5 plus table value of that specific z value. Then this one, probability that z is less than negative a, you follow 0.5 minus table value. If probability of z is greater than a, so 0.5 minus table value. And if probability of z is greater than negative a, so that would be 0.5 plus stable value. And if you have areas between the same sign z values, like both positive and both negative, you subtract the bigger value minus the smaller value. And if you have an opposite signs, like a negative to a positive z value, then you add the areas or the corresponding areas of both z values. Okay? So, to further this one, if you were using z-table from the left, I have made a guide as well. So, this would be how to use, if you use z-table based from the left, you will have these operations. Actually, it's much more easier to use z-table based from the left. Suppose if you have area less than any, like positive or negative, you always have, just find it on the table. Then you get the area. Now, if you have greater than, you just remember that if you have the value, you need to subtract it by 1. And if you have both, if you are looking for areas between, even if it is both positive or both negative or positive and between positive and negative, you only need to subtract the areas. if you use Z table based from the left. So that would be all for this video. Thank you for listening. God bless and keep safe.